Alright, today we're going to be talking about capacitors. So what is a capacitor? Capacitors are devices that oppose a change of voltage. They're constructed by separating two metal plates by some type of insulating material, and that's going to be called the dielectric. Three factors determine the capacitance of a capacitor. That's going to be the surface area of the plates, the distance between the plates, or the type of dielectric used. And a good thing to remember is the greater the surface area, the more capacitance. Current can only flow through a capacitor while it is charging or discharging. Electrostatic charge. A capacitor stores energy in an electrostatic field. Electrostatic just means that an electric charge is stationary or not moving. The electrostatic field is formed when electrons are removed from one plate and deposited on the other. The stretching of atoms of the dielectric is called dielectric stress. The amount of dielectric stress is proportional to the voltage difference between the plates. Capacitors have a voltage rating that should not be exceeded. And moving on to capacitor ratings, the basic unit of capacitance is the farad. A capacitor has a capacitance of 1 farad when a change of 1 volt across its plates results in a movement of 1 coulomb. And that is the formula for it. And the Q equals charge in coulombs, C equals capacitance in farads, and V equals voltage. A good way to think about dielectric stress is it's similar to drawing back a bowstring with an arrow and holding it. So that means it's just storing that energy. So capacitors are among the most used electrical components. They can be used for power factor correction, start windings of many single-phase AC motors, to produce phase shifts for SCRs and triad circuits, to filter pulsating DC, RC timing circuits, and they're used extensively in electronic circuits for control of frequency and pulse generation. So there's two types, non-polarized and polarized. Non-polarized capacitors, they're not sensitive to polarity connection, and they can be connected to either DC or AC circuits. I know that's a typo. Without harm to the capacitor. So they can be connected to either AC or DC circuits. Polarized capacitors are generally referred to as electrolytic capacitors. These capacitors are sensitive to the polarity they are connected to and have one terminal identified as positive or negative. Can only be used in DC circuits. If their polarity connection is reversed, the capacitor can be damaged and will sometimes explode. The advantage of electrolytic capacitors is that they can have very high capacitance in a small case. And in this summary section, I'm going to go over just a few more things with you. So what we've already talked about so far is capacitors oppose change of voltage. The three factors that determine the capacitance of a capacitor are surface area, distance between plates, and type of dielectric used. A capacitor stores energy. in an electrostatic field. And we said that electrostatic means stationary. Capacitors charge and discharge at an exponential rate. Capacitors are generally rated in microfarads, nanofarads, and picofarads. When capacitors are connected in parallel, their capacitance values add. So, parallel capacitance adds. When they're in series, the reciprocal of the total capacitance is equal to the sum of the reciprocals of all the capacitors. So all that means is, let me look at the formula just so I don't write it down wrong. Just how when we're using resistors, you would do the reciprocal. So let's say we've got 1 over capacitance 1 plus 1 over capacitance 2 plus 1 over, I'm saying capacitance, but capacitor 3. So, your capacitance total is going to equal the capacitance, the reciprocal of your capacitance of each capacitor. So just like how when we find resistance, you're going to use the reciprocal method. Non-polarized capacitors are often called AC capacitors. Non-polarized capacitors can be connected to, I'm right around my head, can be connected to AC or DC. We know that. Polarized capacitors are often referred to as electrolytic capacitors. Polarized capacitors can be connected to DC circuits only. So, polarized equal DC only. So, polarized are only DC, non-polarized are AC or DC. And there are, let's see. The last thing is, if we want to test a capacitor for leakage, we got to use a microammeter. And we got to connect it in series with the capacitor and the voltage applied to the circuit.